Our story begins 4.6 billion years ago. The vast emptiness of space held a secret. A giant cloud of gas and dust drifted silently. It was a nebula, a stellar nursery. Then a disturbance rippled through the cloud. Perhaps a supernova, a star exploding in a blaze of glory, sent shockwaves through the nebula. This disturbance caused the cloud to collapse under its own gravity. As the cloud collapsed, it began to spin. Faster and faster it whirled like a cosmic dancer. At the center of this swirling cloud, the temperature and pressure increased dramatically. A star was about to be born. Finally, the core of the collapsing cloud reached a critical temperature. Hydrogen atoms fused, releasing an incredible amount of energy. Our sun, a brilliant star, ignited. The sun's birth was a dramatic event, but it wasn't the end of the story. The remaining gas and dust from the nebula continued to swirl around the newborn star. This swirling disk would eventually give rise to our solar system, our cosmic home. This is how our journey began, in the heart of a collapsing cloud billions of years ago. The early solar system was a chaotic place. Dust and gas swirled around the newborn sun. These particles, remnants of the original nebula, collided with each other. Over millions of years, these collisions had a profound effect. Tiny particles stuck together, forming larger and larger clumps. These clumps, called planetesimals, grew over time. Some planetesimals became massive enough to have their own gravity. They attracted more dust and gas, growing larger still. These growing planetesimals became the seeds of planets. In the inner solar system, where temperatures were hotter, rocky planets like Mercury, Venus, Earth and Mars formed. Farther from the Sun, where temperatures were colder, gas giants like Jupiter and Saturn formed. These planets accumulated vast amounts of hydrogen and helium. Beyond the gas giants, the ice giants Uranus and Neptune formed. They accumulated ices, including water ice, methane ice, and ammonia ice. Over millions of years, the solar system transformed. The chaotic dance of dust and gas gave way to a more orderly system of planets orbiting a star. The early solar system was a dynamic place. It was not the peaceful, stable system we know today. Giant planets migrated, shifting their orbits around the sun. These migrations had a profound impact on the solar system's evolution. Jupiter, the largest planet, played a particularly important role. As Jupiter migrated, its gravity stirred up the asteroid belt. It scattered asteroids like pebbles, flinging some towards the inner solar system. These asteroid bombardments had a significant impact on the inner planets, including Earth. Earth's moon, for example, is thought to have formed from a giant impact early in the solar system's history. The early solar system was a time of great upheaval, but it was also a time of great creativity. The stage was set for the emergence of life on at least one planet, our own. Today, our solar system is a place of relative peace and stability. The planets follow their orbits with remarkable precision. Each planet has found its place in this cosmic ballet. The Sun, our star, sits at the center of it all. It bathes the solar system in light and warmth. Its gravity holds the planets in their orbits. The planets, each unique, are a testament to the solar system's history. Mercury, the smallest planet, is a scorched world baked by the sun's heat. Venus, shrouded in thick clouds, is a hothouse planet. Earth, our home, teems with life. Mars, the red planet, is a cold, dry desert. Jupiter, a giant, is a swirling storm of gas. Saturn, adorned with its majestic rings, is a breathtaking sight. Uranus and Neptune, the ice giants, are mysterious worlds in the outer reaches of the solar system. The solar system is a dynamic and complex system, yet it is also a place of remarkable order and beauty. It is our cosmic home, a place we are only beginning to understand. Section 5. The Sun's farewell, entering the red giant phase. But even stars don't last forever. In about 5 billion years, our Sun will reach the end of its life. It will have exhausted the hydrogen fuel in its core. The Sun will begin to change. It will expand dramatically, becoming a red giant star. This expansion will be a slow and gradual process, but it will have a profound impact on the solar system. The inner planets, including Earth, will be in peril. As the Sun expands, its outer layers will engulf Mercury and Venus. These planets will be vaporized, their material absorbed into the expanding Sun. Earth will be spared this fiery fate, but it will not escape unscathed. The Sun's increasing luminosity will boil away Earth's oceans. The planet's surface will be scorched, leaving behind a barren wasteland. The red giant phase will be a time of great upheaval for the solar system. The inner planets will be consumed or rendered uninhabitable. The outer planets will migrate outward, their orbits disrupted by the sun's changing mass. Section 6, a planetary swan song, the fate of our cosmic companions. As the sun expands into a red giant, the outer planets will experience their own dramatic changes. Jupiter, the largest planet, will migrate outward. Its gravitational influence will shift the orbits of the remaining planets and asteroids. Saturn, too, will migrate outward. Its rings, composed of ice and rock, will slowly dissipate as they're bombarded by solar radiation. Uranus and Neptune, the ice giants, will also migrate outward. They may even be ejected from the solar system entirely, becoming rogue planets wandering the vastness of interstellar space. The asteroid belt, a ring of rocky debris between Mars and Jupiter, will be scattered. Asteroids will be flung inwards and outwards, some potentially colliding with the surviving planets. The once familiar architecture of our solar system will be rearranged. The planets, once bound in a delicate gravitational dance, will be scattered and disrupted. The solar system will become a shadow of its former self. Section 7, the solar system's curtain call, a whisper in the cosmos. After 1 billion years as a red giant, the sun will have exhausted its helium fuel. It will begin to pulsate, shedding its outer layers into space. These ejected layers will form a beautiful planetary nebula, a glowing cloud of gas and dust. At the center of this nebula, the sun's core will remain. This core, no longer able to sustain nuclear fusion, will cool and contract. It will become a white dwarf, a stellar remnant incredibly dense and hot. The white dwarf will slowly fade over billions of years, eventually becoming a black dwarf, a cold and inert object. The remaining planets, stripped of their atmospheres and their orbits disrupted, will continue to orbit the white dwarf, but the solar system as we know it will be gone. The once vibrant solar system, filled with the potential for life, will be reduced to a scattering of dead worlds orbiting a dying star. Our cosmic neighborhood will become a quiet corner of the Milky Way galaxy. Section 8. The universe's grand finale, a cosmic mystery. The fate of our solar system is a microcosm of the fate of the universe itself. The universe, too, is expanding and evolving. Its ultimate fate remains one of the greatest mysteries in science. Several theories attempt to explain how the universe might end. One theory, the Big Freeze, suggests that the universe will continue to expand indefinitely. As it expands, it will cool, eventually becoming a cold, dark, and empty place. Another theory, the Big Crunch, proposes that the universe's expansion will eventually reverse. Gravity will pull everything back together, leading to a catastrophic collapse. This collapse, a reverse of the Big Bang, would be a cosmic reset button. A third theory, the Big Rip, suggests that the expansion of the universe is accelerating. This acceleration, driven by a mysterious force called dark energy, will eventually become so powerful that it will tear apart galaxies, stars, planets, and even the fabric of space-time itself. The fate of the universe is a topic of ongoing scientific inquiry. New discoveries and observations constantly refine our understanding of the cosmos. The end of the universe, while billions of years in the future, is a reminder of the vastness and mystery of the cosmos. Section 9, beyond the end cycles of creation and destruction. The end of the universe, whether it be a big freeze, a big crunch, or a big rip, may not be the end of everything. Some theories suggest that even after the universe as we know it ceases to exist, new universes might arise. This concept, known as a multiverse, suggests that our universe is just one of many universes, each with its own laws of physics and its own unique history. The end of one universe could be the beginning of another. The cyclical nature of the cosmos, with its endless dance of creation and destruction, is a humbling thought. It reminds us that we are part of something much larger than ourselves. The universe is a vast and mysterious place. It is filled with wonders that we are only beginning to comprehend. As we continue to explore the cosmos, we deepen our understanding of our place in the universe. We unravel the mysteries of the universe and gain a deeper appreciation for the beauty and fragility of our own planet. The journey of discovery is never ending. The cosmos, with its endless wonders, will continue to inspire us for generations to come.